In case of cyanides, the prefix name for cyanide is cyano. Suffix name is nitrile. In case if you have something like CN here, cyanide, the numbering will always start with the carbon of that particular cyanide group, which will be given the high priority. And then it will become cyano, right? So this would be read as nitrile. So this will become pentan plus nitrile. Now here it is starting with N, so I can't delete this E also. So you have to write it as pentane nitrile. Okay. Complete name will be pentane nitrile. Got it? Even if you have in a cyclic form, let's say I have CN here and a double bond here. Numbering would start with cyanide here. But this carbon is not coming on the count of the root chain. In that case, this will be written as cyclopent 2 in, complete in, and then carbonitrile. So this will become carbonitrile. So which means the suffix name will also be carbonitrile. Carbonitrile. Okay. See, in a lot of cases, suppose if you have a cyanide here, and let's say I have a methyl here, Me, correct? There is another very common name that can be written as a cyanide. So when you are using it as a cyanide, then the numbering must start from here, like 1, 2, 3, 4, 5, 6. So we'll search for the longest chain, and then we write it as a cyanide form. So we will say this as hexane cyanide, hexane 2 cyanide. Got it? That carbon is not counted, and it is counted as a cyanide. But this is not IUPAC. Just I'll put down here, not an IUPAC name. Okay.
Sir,
Yes, beta.
can I clear a small doubt from the basics?
Yes, tell me.
Sir, actually in the isoalkane series, isooctane is an exception, right?
Yes, beta.
So in that structure, actually the second last carbon has two
Two
what we say.
groups.
So like if we start from the other end, then can it be called as neo also? Because from the if we see from the end, then it acts like neo also. So can we call it neo octane also?
Okay, good question. Check it out. Now, suppose if you have connection here, let's say this is the main chain, and I have this kind of connection, then you call it as neopentane.
Yes, sir. Octane.
Neopentyl. I'm writing pentyl now.
Okay.
Correct? Now, suppose if at all I have to write the neohexyl, then this connection has to be there. This should be the same way, except here one extra amount of methyl group should be present. Correct? And this is neohexyl. Got it? Now, if I want neoheptyl, in that case, this should be the same thing. Okay. And here I should have one more developed. Clear now? So now this will become neoheptyl. Got it?
Sir, why should that be one more developed?
Because this carbon, the carbon which is connected to the main chain, just adjacent to that carbon only, we should have that 4 groups. Then only we call it as neo. Got it? And that's why when it comes to octyl also, in case if you want to call it as octyl, then this one, and this one. If you have this way, then you can call it as neo-octyl. Got it?
Sir, actually this line structure is a little bit confusing.
Like what I'm saying, I have CH2 connected with carbon.
Yeah.
Then I have CH3 CH3,
Hmm.
CH3. If this is how it is connected, and this is neopentyl, है ना?
Hmm.
If I remove this carbon here, CH2, and continue with one more CH3, this will become neohexyl. And if I continue with one more CH3, neoheptyl, continue with
Ah.
one more CH2, CH3, then that will become neooctyl. Okay.
Ah.
So it should be just the second carbon from the main chain. Okay. Then only it is neo. Isooctyl is not like that. No, beta. Isooctyl is like this 1, 2, 3, 4, 5. Here, this is where the connection is, and here there are two more. Correct?
Ah.
This is isooctyl. So this cannot be called as neo because it is not coming on the second carbon here, isn't it?
Hmm.
Yeah, understood?
Sir, but actually actually in my class the structure which sir wrote for isooctyl.
Hmm.
So in that he wrote that structure in second last carbon.
This one, no?
Huh.
This is isooctyl only, no? It is not neo. I'm saying neo is this one. This is different than this one, right?
Hmm.
Got it?
Just a minute.
Hmm. Usually neo are not used, okay?
Okay. Okay, sir. Understood.
Hmm. Yeah, beta. Chalo. Let us go ahead now. See now. This is about the cyanide part. Cyanide is easy one. Next, eighth one is about aldehydes. Aldehydes as a family will have a structure as RC double bond OH. The prefix name for aldehydes is either oxo or formyl, and suffix name for that will be al. Simply you would write it as al or carbaldehyde. Either of these names should be used. For instance, if I have here C double bond O and H, the numbering must start from here. So 1, 2, 3, 4, 5. The name for that is pentanal. Pentanal. Okay. But if it is in a cyclic chain, like C double bond OH, and let's say some double bond is here. So this is cyclohexane. Numbering will start from here 1, 2, 3, 4, 5, 6. And on second position, we have N. And I have to write complete ene now. Ene and then carb aldehyde because it is not coming as a part of that chain. Okay. I guess this part is clear, everyone. Next. This is the part of aldehydes, beta. Straight aldehydes. Ninth one is ketones. Ketones usually have double bond O like this, and both sides we can have some alkyl groups. Prefix name of ketone is oxo as well as keto. Both can be used. The suffix name is only one, O-N-E, one. Okay. For instance, if you have a double bond here like this, you make sure that this double bond always comes at the lower numbering. So I'll go from left to right. So 1, 2, 3, 4, 5, 6. So this will become hexanone. Hexanone. So, but it is present at third position. So we'll write it as hexan 3-one or 3-hexanone. Either ways, it is correct. In case if you have it in the cyclic structure, double bond O, double bond, That carbon is anyway counted. You will start with numbering 1, 1, 2, 3, 4, 5, 6. And on second position, I have ene. So this will be hex 2n, 2n on, cyclohexane. So it is cyclohex 2n and 1 on. So this is the name you will write. So for ketones, you will not have something like carb type of name. It will always be counted. The double bond will always come in the count. 10th one is alcohols. Alcohols are represented as RCH2 OH group. Some OH group should be attached. So if you have something like OH here and let's say CH3 here, numbering must start from the lower OH groups 1, 2, 3, 4, 5. So we have this here as 4-methyl pent and you have to write pent and 2-ol. There should not be E here because it is ending with suffix is ending with O. Similarly, if you have multiple of them, let's say there is one OH here and there is one OH here. Numbering must start from right to left. So 1, 2, 3, 4, 5, 6. So it is hexane. So we'll write it as hexane, correct? Then 2, 4 diol. So complete name hexane and then 2, 4 diol. Okay. Suppose if you have a double bond here, OH is here like this. Okay. And I have to go for the numbering. So you should always choose not like this. Just try to keep it a little bit more confused like this. This is how it is. Now you need to choose longer chain length, which would have a double bond contained in it. Now, suppose if I go this way, 1, 2, 3, 4, 5, or either ways, I'll write it this way, 1, 2, 3, 4, 5. You can see OH is not getting a priority. OH is falling on the branch. So this is not correct. Your numbering should start from where OH is present. So we should start from here, 1, 2, 3, and 4. So what should be the name now? So 2-ethyl but 3-ene 1-ol. So but 3-ene 1-ol. This will be the correct IUPAC name. Clear with the alcohols part? Next, 11th, amines. We have RNH2. This is the family. The prefix name here is, I didn't write the prefix name here, sorry. For alcohols, let me just push this down. The prefix name for alcohol is hydroxy. And the suffix name for the same is ol, ol. Hydroxy and suffix name is ol. For amines, the prefix name is amino, while the suffix name for that is amine. So it will be amine. So suppose if you have NH2 here and ethyl group like this. So you will start numbering simply from here. 1, 2, 3, 4, 5, 6. You will need to find the longest chain where NH2 is coming as a count. So this will be hexane, and 3-amine, hexane-amine. But in case if you have like this, we have NH2 coming here, correct? And we have double bond here. In that case, you need to go in the line of double bond. So numbering should be from here, 1, 2, 3, 4. And on the second position, I have propyl. So the naming should be 2-propyl, and but 3-in 1-amine. You can write 1-amine or simply amine. It is still going to be fine. Clear on that? Next. In case if you have, this is very, very important and interesting also. If you have NH, instead of that, there is one methyl group here, CH3 instead of hydrogen. And then there is one more methyl group here, correct? In that case, how do we name it? The numbering must start from here, from the immediate carbon of nitrogen. So 1, 2, 3, 4. So we will be searching for the longest chain. And now on N also we have methyl, 2 also we have methyl. So you can write it in two different ways. You can write it as N comma 2 dimethyl, N comma 2 dimethyl and butanamine, butanamine. And then in case if you have it the other way around, you can also write it as N-methyl, then 2-methyl, N-methyl, 2-methyl, butanamine. Correct? You can write it separately also. You can combine it also. It'll give the same naming. So no problem there. Suppose if you have N here, there is one group like this. There is one group like this. In that case, first search for the longest chain. So you can see longest chain is on the left hand side. So 1, 2, 3, 4. And these two are now termed as N substitutes. So it is N. This one is isopropyl. This one is ethyl. So ethyl will come first alphabetically. So N-ethyl, N-isopropyl, N-isopropyl, then butanamine. This is I accepted IUPAC name, or I can also write it as N-ethyl, N. This is nothing but methyl ethyl. So I can also write as N methyl ethyl, but in brackets, because whenever you're writing a complex substituent, we always use brackets. So N methyl ethyl butanamine. Guys, I hope you understood how to write the amines now. Yeah. So whenever you have multiple type of amides, this is how we will show that. And lastly, the functional group wise, only these are the ones which are functional group ones. Next one are ethers. Ethers will have the formula ROR. This is only prefix, no suffix, because IUPAC, this is not considered as some functional group. It is only substituent. And that substituent name is alkoxy. So suppose if you have a compound like O and like this. Now see the number of carbons, 1, 2, 3, 4, 5. So you would figure out the longest chain, and this entire thing, you will read it as an alkoxy group. So therefore, the naming would be, here there are two carbons. So this will become ethoxy. Ethoxy, and this is pentane. And you don't have to show the numbering here because it is on one carbon only. So it is simply ethoxypentane. Suppose if it is on some other numbering like this, I have O and methyl here. In that case, you will go for the longest chain 1, 2, 3, 4, 5, 6, 7. On fourth carbon, you are getting that methoxy. This is now read as methoxy. So it will simply be read as 4-methoxy. 4-methoxyheptane. Next, if you have it in the cyclic case also, like this, I have this way. So obviously the left hand side has more number of carbons. So that will be the principal chain or root chain 1, 2, 3, 4, 5. So this is pentane. And this entire thing is isopropoxy. So I can write it as isopropoxy, isopropoxy cyclopentane. Please go through it once. Linda, Nanta, if you have any doubt, you can ask me later. Nihar, any doubt here?
No, sir.
Nandita, how about you?
No, sir.
Vrinda?
No, sir.
Great. So whatever we have discussed, beta, these are all the IUPAC names which you need to know. In this ethers only, there is one more type known as the cyclic ethers. Cyclic ethers. Cyclic ethers IUPAC is based upon two segments. One is based on number of based on ring size, or it is based on oxy connection. You can use both the IUPACs, both of them are acceptable. Let me start with this one. Suppose I have a pentane here and there is an oxygen connection like this. This is the ring ethers or cyclic ethers. You will start just like an alkane naming, and this is the this is the least locant numbering. And on 2 and 3 positions, there is an oxy connection, right? That oxy is read as epoxy. So 2, 3, epoxy. And this is pentane. Got it? So it is just mentioning up that there is a oxy connection there. So that's how we will write it as, epoxy pentane. IUPAC have decided, that whenever there is a 3-membered cyclic ether, we can always call that entire group as oxyrane. We can call it as oxyrane. Now, this is one accepted IUPAC, but the strict IUPAC, which means strictly what IUPAC we should use right now, is we should consider this as a functional group now. So let me copy that once again. We need to consider this as the functional group, this entire thing as a functional group, and that has a complete different name known as the oxyrane. And the numbering must start from oxygen and go to the side based upon the lowest locants as well as the alphabetical order. So you can see here methyl comes before propyl. That's why methyl got second numbering. Now the name would be 2-methyl, 3-propyl, oxyrane. This is another name, and this is the strict IUPAC name which it is to be followed. Okay. Next. Suppose if you have a ring like this is how the ring connection is. Old IUPAC, which is still accepted. So in case if you come across multiple questions, you still have to choose this epoxide, okay? And this has been questions in JE, like IIT in advance, they have asked earlier also that both names were given with respect to epoxides, also with respect to oxyrane. You have to accept both of them. Here, if you start numbering 1, 2, 3, 4, 5, 6. So the epoxy connection is established at second and fourth position. So that's what we will name it. So 2, 4, epoxy hexane. This is old IUPAC and it as well accepted. But the new IUPAC, if you see, when it comes to 4-membered ring like this, it has a separate name just like oxyrane. It is called oxytane. This is called oxytane. Okay. So 2, 4, 6, instead of using that, now what do we, if the same molecule is given, how do I name it? Check it out. So numbering should always start from oxygen end. So this is number 1. And then this side there is methyl, this side there is ethyl. So alphabetically, ethyl should be preferred more. So 1, 2, 3, 4. So the naming should be 2-ethyl, 4-methyl, oxytane. Okay, this is the IUPAC name. The strict IUPAC, if it is in a mains question, if it is single correct, this is more to be chosen. This you should not choose. But if it is multiple correct question, both are correct. Okay.
Sir, can you repeat this once?
What I'm saying, see, oxytane is the family name for that cyclic ether. 1, 2, 3, 4. This is oxytane. Fourth position, I have methyl. Why fourth position? This starts with M, this starts with E. So I've given more preference to ethyl. So here we have ethyl, here we have methyl. So 2-ethyl, 4-methyl. This entire family name is oxetane. Okay. And what I said, in case if you come across this question in mains, you will choose this one as the correct one, not this one. But if it comes in advance and you have multiple correct, then you can choose both of them as correct. Clear?
Sir, why in mains we can't choose that
Mains is single correct, na beta? Mains fundamentally
Acha,
you need to choose the best
so
option.
okay, so the best one is second one.
Yes. Okay.
Okay.
In mains, lot of questions, especially in physics, you'll get a lot of controversies like that. Okay. So you are expected to choose the best option possible. Whenever there is a confusion. Right. So these are about the ether forms. More or less by all functional group, we have done it. Now we will have to enter into polyfunctional groups. Polyfunctional groups. Polyfunctional groups implies that we need to have what we call the priority order. Like out of all the compounds, which one need to be given more priority? Got it? So once you know the priority order, it becomes easy for you to figure out what should be the name of that compound. What do you mean by this priority order, everybody? See, if you have 2, 3, or more than one functional group, out of all those functional groups, you have to fix one as the main functional group. Then the rest all will become the substitutes only now. Now they don't be called as functional group anymore. So let me write down the priority list. Priority list, if you check it out, the first priority is an acid. So COOH. Then first is carboxylic acid. This next is sulfonic acid. Then comes anhydride. That is C double bond O, O C double bond O. This is anhydride. Next comes esters. C double bond O OR. This kind of connection, ester connection. This next comes acid chloride. Next comes amides, RCONH2. Okay. Next comes cyanides. Next comes isocyanides. Like this. Cyanide is C triple bond N. I'll write the complete structure. Cyanides, then isocyanides. Next comes aldehydes. That is C double bond OH. This is aldehyde. Next comes ketones. C double bond O and this ketones. After that comes alcohols. Then comes thioalcohols. Then comes amines, RNH2. Okay. After this comes double bonds. After this comes triple bonds. Correct. And then finally, here all of them are only branches. That is substitutes. Here there is no priority. This you have to mug up. You have to write multiple number of times and learn it. Because this becomes a very important part as you go throughout the entire organic, chemistry. Everyone, first acid, carboxylic acid, sulfonic acid, then anhydride, then esters, then acid chlorides, amides, cyanides, isocyanides, aldehydes, ketones, alcohols, thioalcohols, then amines, then double bonds, triple bonds, and finally all branches. Okay. Keeping this in mind, accordingly, you have to select the principal functional group. This is for priority list for note used for selection of principal functional group. Principal functional group. Okay. Now let us do a few examples. I want you to do it along with me. First, make sure you have written the priority list, everybody. And Vida, Nihar, Vinda, please write the list, beta.
Yes, sir. Sir, is there any short trick to by heart?
I'll give you some mnemonics on this. Okay. There are some mnemonics. You can remember it that. Done. Faster. We have to do a lot of questions now. Linda, copied?
Almost, sir. Just on the last line.
Right.
Yes, sir.
Let's see this. Suppose if this compound is given based on the above priority order, this is a keto group, this is an acid group. So acid will get more priority. So numbering should start from the acid carbon 1, 2, 3, 4, 5, 6. See the names now. Ketone can always be used as a keto or an oxo. So both names are correct. So the naming would be I have 5-oxo, 5-oxo hex 3N oic acid, 3N oic acid, or simply 5-keto, 5-keto hex 3N oic acid. You write it in terms of oxo or keto, both of them are correct. No problem with that. Complete writing. If you're getting stuck somewhere, see, I'll keep helping out on every question for now. You try to understand how I'm using the priorities, okay? Make a note of it. Let's do the next one. I have COOH here, CN here, NH2 here, double bond O here. Again, what do I name it? Numbering will start from COH. So 1, 2, 3, 4, 5, 6. Have you noticed what I'm doing? Once the priority is decided, functional group is decided, we will go in the direction where you will get maximum number of carbons, which can accommodate a lot of double bonds. Keep that in mind. Now, writing the name here again, check. On third position, I have cyano. Fourth position, I have amino. And fifth position, I have keto. So, by the alphabetical order, amino should come first. So, 4 amino, 3 cyano, and 5 keto. You can take keto also or oxo also. Then, hexanoic acid. Then we have hexanoic acid. Make a note. Nandita, have you understood the first two?
Yes, sir.
Good. See the next one.
Excuse me, sir.
Yeah,
Sir,
tell me.
but CONH2 should come before CN, right?
CONH2.
Ah,
Watch it carefully. It should be directly connected. CONH2. Then only it is amide. Here, this is COOH and this is only NH2.
oh, okay, okay.
Got it?
Yes.
They are different groups. Next, third one. See, while numbering, this is the more tricky ones. You will start with COH for sure. So 1, 2. You will go this side. 3, 4. Don't think, sir, OH is priority. Once one has been given the functional group, everything will be substituted. Now you will go in the direction where you can find the longest carbon chain with maximum number of double bonds, which means even though if you have a methyl group here, left hand side, you might think, sir, if I go this way, 1, 2, 3, 4, 5, I'm getting 5-membered ring. I'm getting a length of 5 carbons. But if you go 1, 2, 3, 4, you're getting only 4 carbon. But this is the correct numbering. Reason? The double bond should always be preferred along with the functional group. Okay. So keep that in mind. You have to move in the direction where functional group gets the priority first, followed by the longest chain with a double bond. Okay. Now, what is the name? You can see on the second position, I have 1, 2, 3 propyl. And on the first carbon of that propyl, we have hydroxy. So this will be 2 hydroxy, 2 hydroxy propyl. Keep it in bracket. And then it is but 3N, 3N oic acid. I hope you guys understood that, what I have written. Vrinda,
Can
is
you
that?
explain again, please?
Should I repeat?
Yes, sir, please.
See, what I said, you have to go in the direction where you can get the maximum carbons accommodated along with a double bond. So COOH is a functional group, so your numbering should start from there. Next, you have to go in this direction. So if you go in this direction, now on the second position, I have 1, 2, 3 propyl group. And in the on the propyl group, I have one hydroxy. So it will be on second position, I have hydroxy propyl. And on the third position, I have ene. So it is total 4 carbons. So it is but. And on third carbon, I have ene with oic acid. Got
Sure,
it?
sir. Thank you.
Right. See the next one.
Sir, can we try this by ourselves? This one.
I'm giving you first 5 just for sake of understanding. Then you will only do it. Okay. I'll be giving you it. Don't worry. Let me just get you into the ideas properly. Okay. Check this out. This is the last one. Then I'll give you. See. Again, I'll check out immediately here. There is cyanide, there is keto, hydroxy, and these are anyway not functional groups only. So between that, cyanide is the most favorable one. So 1, 2, 3, 4, 5, 6. And by alphabetical order, bromine comes first. So 5 bromo. And then chlorine comes for next. So 3 chloro. Then hydroxy comes next. So 4 hydroxy. 4 hydroxy. Then 2 keto. Then 2 keto. This is hexane nitrile. This is complete hexane nitrile. Okay. Check if you are able to crack that. Done.
So why do we call it nitrile?
CN's functional name is nitrile.
So, but then we used cyanone in the second one, right?
This is a main functional group, beta. Why do we use cyanide again?
Okay, sir.
Priority wise, that is the one. See here, cyanide. This is nitrile. Nitrile is much more priority than aldehydes, ketones, alcohols, everything.
Yes, sir.
Fifth one. Do it now. Do it yourself. Faster. Nihar, would you say?
Sir, 1 minute. Sir, first preference is to OCCl2, then CHO, then OH, right?
No. First, again, you are talking the language in a very different manner. I just told you, beta. Once you decided the functional group, that COCl is a functional group. उसके बाद
Yeah.
आप ये क्यों बोल रहे हो? उसके बाद ये आएगा, उसके बाद वो आएगा.
क्योंकि तो अरे वो जो दैट्स व्हाट वी से दैट सीरीज
बेटा इसके लिए मैंने फिर से बोल रहा हूँ, आप ध्यान से सुन नहीं रहे हो. मैंने केवल एक बार डिसाइड हो गया ना, बाकी सबका लेवल एक ही है अभी. एक डिसाइड होने के बाद बाकी किसी का अभी OH नहीं रहा, अभी CHO नहीं रहा.
Okay, so then we have to look for the longest chain.
That's all. Longest chain.
Okay.
And these are only substitutes after that.
I was getting confused in that one. Oh, sir,
No.
okay. Yes.
Nandita and Vrinda. I think this might be a confusion for you guys also. Please make sure what I'm saying. Please listen to that once again. Once you get a fix of a functional group, rest all will be at the same level. Now there is no priority order you have to apply. Okay. So numbering will start from here. 1, 2, 3,
Sir, हाँ
4, 5. यहां तक तो ठीक है. इसके बाद आपको बताना है 6 किधर जाएगा.
Towards the left.
Very good. 6, 7, because this is the longest chain. Now we don't think that अरे CHO है तो उसको priority देना है. Okay?
हाँ.
Because functional group is decided. Now you just have to check out for the longest chain, which can accommodate maximum double bonds. So double bond तो आ गया उसी के ऊपर. Vrinda, Nandita, is that clear, beta?
Yes, sir.
No.
Yes, sir.
Okay. Now give the naming. On fifth position, what do we call? What is the name for this one? If there is only CHO and it is not counting as a carbon count, that is called as formyl, right? This is called formyl. And this is
Hydroxy.
hydroxy, and there is a methyl also in between. So this is read as hydroxymethyl. This is read as hydroxymethyl. Okay. Now, by alphabet, which one is coming first? E,
Formyl.
F, G, H.
Formyl.
Formyl will come first. So 5 formyl.
2
5
hydroxymethyl.
formyl. And then
2
2
hydroxymethyl.
2 hydroxymethyl. Okay. And then hept 2N. And after that, COCl को क्या बोलते हैं? OL chloride. Remember? That is a suffix name.
Sir, I have
Yes,
a
sir.
question. Sir, how is that methyl? Isn't it only CH2 in the middle there?
There is a CH2 here on which there is an OH group. So it is actually supposed to be methyl, but on that methyl I have one more group. So that's why you have to read that first. So
Okay.
hydroxymethyl. Got that?
Yes, sir.
Right. I guess this one is done. Next, check this out. Suppose if you have C triple bond N, this carbon is connected to double bond O and COOH like this here with OH group here like this. Name it.
Need my watch. Need my watch. Have my watch. Thank you. Oh.
Sir, that is isocyanate, right? And triple bond C.
What, beta?
That N triple bond C is isocyanate, right?
No, beta. Connection is it this on the main chain? It is connected from carbon end or nitrogen end? Carbon end.
Carbon
It
end.
is cyanide only.
Okay, sir.
Done?
Yes.
So numbering see 1, 2, 3, 4. Now this cannot get 5 because we don't have any name with carbon getting a 5 and then there is triple bonded and has some name. Okay. So therefore, what is the name now? You know that this group starts as cyno. This is
Hydro.
hydroxy,
Huh.
while this is keto or oxy, whatever you can choose. So alphabetically, cyanide food should come first. So this is going to be 4 cyno, 4 cyno, then 3 hydroxy, then 2 keto,
Butanoic acid.
butanoic acid. So this is how we need to figure out. Clear?
So why isn't it a 5 chain? Isn't there a carbon at the end?
Hmm?
At the end, why isn't it a 5 chain?
See, beta, this carbon, if you want to number, then how do we represent that there is a triple bonded nitrogen? Do we have any separate name for it? No, right?
No, sir.
That's why we need to stop the chain here itself and then
Okay.
take this entire cyanide as a substitute. Okay.
Okay, sir.
On the similar lines, think this way. Double bond NH2 COCl OH with a double bond here. Name it.
Done, sir.
Good. Numbering must have started from here. So 1,
COC.
2, 3, 4,
7.
5, 6. 1, 2, 3, 4, 5, 6. Did you count this now?
Yes, sir.
Yes, we can count that. Why? Because we know this has a name, oxo.
Hmm.
And this NH2 also has a name, amino.
Yeah.
Now we can choose that. So therefore, we have 6 amino, 6 amino.
Sir,
3 hydroxy.
I didn't get actually. Sir, like I chose 7
How come 7 are there, beta? There are only
because
6 carbons.
6 will be keto, right? And 7 will be
That is not
amino.
carbon, na beta. You should give numbers to only carbon. Nitrogen does not get a numbering and straight chain.
Yes, sir. Yes, sir. Okay.
Okay.
Sir, so it will be 6 like keto amino like that.
Correct. 6 amino also and 6 keto also. Alphabetically, I'm writing. That's why. So 6 amino, 3 hydroxy, and then again 6 keto or oxo. You can write either of them. Then it is hex 4 in and 4 in OL chloride. Okay. Check it out. Linda, have you understood?
Yes, sir.
Great. Suppose if you have same thing, C double bond O, Cl double bond O, H. No, I will not write Cl, NH2. NH2. And then I have chloride here, like this. Now what should be the name?
Sir, the numbering will start from left side, right?
Hey, beta.
The numbering will start from left side.
No, amides are more priority than aldehydes. Right? 1, 2, 3, 4, 5. Now I want you to understand whether I should give that 6 or not.
So there is a C there, right?
Yes, beta. There is a C double bond O here.
Yes, so there will be a 6.
Right. So we can give 6. Now, usually problem here is if you give this as a 6, correct? We usually read it as oxo. On 6th position, there is oxo. Hai na? But to avoid the confusion that this is an aldehyde or a ketone, what we do, this double bond O, if it is not connected with anything else here and only hydrogen is present, then we will take it separately like a formyl group. So we'll take this as a formyl group now. Both are accepted, but this formyl case has been more accepted in, JEE, as well as I have seen it coming across in various Olympiad exams also. There also they have used formyl more rather than ketone. And this is only the case where when the aldehyde is present. Ketone is present, definitely it is always keto or oxo. Guys, have you understood what I'm saying? So now I will keep that 5 like that. And on the 5th position, I have formyl. Now I'll read this as formyl group. 3rd position, I have chloromethyl. Rest all is the name, no name. So chloromethyl will come first alphabetically. So 3 chloromethyl. 5th position, I have formyl. And this entire thing is pentanamide. Pentanamide. Check. Yeah, is that clear?
Yes.
What is the other name? Nandita, you have said that better. You can tell me now. You can read it as 6 and then write it as 6-oxo or keto. So this will be 3-chloromethyl and then 6-oxo heptanamide, hexanamide. Hexanamide. Okay. I'll give it a double tick, which means more accepted. This is less accepted. Okay.
Sir, suppose see in the exam, they won't give both options, right?
That's why I said, beta, if mains is coming and both options are there, then you choose this one.
Okay, sir.
Okay. If it is in advance, you can choose both of them in multiple correct.
Yes, sir.
Now, see some special groups now. Special namings. The first one is, the first special naming we will see is when you have multiple functional groups and you are not able to cover all the functional groups, right? Sorry, let me tell you. Multiple number of a particular functional group. Which means, suppose I have COOH here and COOH here. This I'm first taking like an example, then I'll explain you why that need of this new naming has arisen. So suppose if I have to name this, first I will start from here 1, 2, 3, 4, 5. I will be covering the entire carboxylic acids, and I would say that at 2, 4 I have dimethyl. And then this is pentane, complete name pentane 1, 5 dioic acid, which is perfectly fine IUPAC name. Now the problem comes when you have, there is one more COH group here now. So COOH and COH is there, and again I have one more COH group. Now if I go as per the traditional numbering 1, 2, 3, 4, 5, have you noticed that this carbon is getting no priority? It is not getting the numbering. That carbon is not getting numbering, correct? Which means if you have more than two similar functional groups like carboxylic acids or what do you say, aldehydes and ketones and so on, this becomes difficult to get all the carbons in priority. Now the old IUPAC used to read it like this: 3 carboxy. They used to read it this way, and rest all the name is same: 3 carboxy. Next one is 2, 4, 2, 4 dimethyl pentane 1, 5 dioic acid. This was as per the old IUPAC. Okay. The IUPAC rules were revised in 2007. So before that, they used to use this. But after 2007, they have changed it to what he said, that in case if all the similar functional groups are not getting priority, then give the long chain, give alkane as the main chain. So now you see what is the main chain here. This will become the main chain now. So we will have this as 1, 2, 3, 4, and 5. Okay. And on the second, third, and fourth, we have carboxylic groups. So we will write this as pentane, complete name. Pentane, complete name. And then we have 2, 3, 4 tricarboxylic acids. Tricarboxylic acid. Okay. Clear, beta? All three are now getting the priority. Linda, have you understood what it is?
Yes, sir.
Nandita?
Yes, sir.
Right. Nihar, clear, beta?
Yes.
Right. So let me take few more examples like that. Suppose if you have a cyanide here a cyanide here, correct? And one more cyanide here. Now, how do I start numbering? You look out for the longest chain, which have all the cyanides possible. So the numbering start from here. 1, 2, 3, 4, 5. So as per the new IUPAC, this is actually pentane. So we'll write that complete name as pentane. And then 1, 2, 3 has tri-carbo. You write it as carbonitrile. Carbonitrile. So you have to add that word carbo. Okay. Same thing is valid even for aldehydes. Suppose if you have this way CHO, right? Then I have CHO. Then I have CHO like this. Okay. Aldehydes. The numbering again starts from here. The adjacent carbon 1, 2, 3, 4, 5. So again, this is pentane. So complete pentane name, and then 1, 3, 5. We have tricarb aldehyde. So this is a special IUPAC name, how to name them. Okay. So I think given any case where you have more than 2 groups like that, you have to use it. Okay. Done. Next. The second special IUPAC is used when you have multiple rings, correct? Multiple rings connected by straight chains. Suppose if you have this way, then we will have 1, 2, 3, 4. This is the main chain, because 3 cycles and 4 cycles, if we compare, 4 cycle is the main chain. And we will have on one position, we have cyclopropyl. So cyclopropyl, cyclobutane. But imagine the same thing now if we have one CH2 in between, which means I have one straight chain now. The minute we have at least one straight chain present, then that will only be given the priority. अगर दो cycles के बीच में, if there is any straight chain as small as possible, that will be given the priority, and that will become the numbering. So this will be 1. Okay. Now left hand side and right hand side, we read it as 1, 1 cyclopropyl, and the right side is cyclobutyl. Alphabetically, butyl will come first. So cyclobutyl, 1 cyclopropyl, and the name is methane. Got it? Single carbon, so it is methane. Nihar, have you understood that?
Uh, 1 minute.
Chalo, name this third one. If you have understood that, then name the third one. 1 second. Nihar, will you care to answer this?
Uh, one cyclohexyl,
Very good. So numbering start from 1 and 2 here. Very good. So
one
1
cyclohexyl,
cyclohexyl,
and two cyclopentyl
2 cyclopentyl.
pentyl.
Complete name is ethane.
Yeah,
That is simply
yeah,
ethane.
two carbons.
Okay. Let us do one more. Nandita, please do that. Give me the name.
Yes, sir. 1 minute.
Vrinda, chemical equilibrium has started for you.
Sun Akash, yes, we've started it from the last class. We've started with equilibrium.
Nandita, how
Sir,
about you?
No, sir. We started IUPAC and mole concept.
Oh, sorry, sir. So not equilibrium. We started with thermodynamics, then with equilibrium.
Okay.
sir, I started with thermodynamics and physics, and then chemistry. I started with ionic equilibrium. We started with ionic equilibrium.
So
Yeah,
you guys didn't do thermo
no, that sir will do after this, I think.
after December.
Yes, and now we have completed chemical equilibrium, and we have started with ionic.
Okay, got it.
But in ionic, actually, sir has only explained that acid, bases, and salt.
Yeah, it's just the beginning, first class only. RK is teaching or Pawan sir is teaching? Ionic equilibrium. Nihar, who's teaching? Pawan sir is teaching?
No, Manoj sir.
Manoj sir, okay.
Pawan sir is teaching organic.
He's only teaching organic, okay.
We finished chemical bonding today.
Sir, should I try?
Yes, beta. Give me the name.
2 cyclobutyl.
2 cyclobutyl.
Yes, sir.
Check once again. Why are you not going from this numbering 1, 2, 3 so that will become longest?
But sir, doesn't the other side have more carbons?
Hmm?
The one on the left. Yes, sir. Yes, sir.
You need to
No.
go for the longest chain, no, beta? When you
Yes,
have
sir.
multiple cycles, okay?
Yes, sir.
So now guess what is the name?
So 1 second. 1 cyclobutyl.
Hmm.
2-cyclohexyl,
Hmm.
3
This is not
methyl.
cyclohexyl. With the ring, if it is there, it is phenyl. Correct?
Yes, sir. 2-cyclo,
Then 2-phenyl. I'm
2-phenyl.
writing alphabetically. And then it is, sorry, not methyl. Sorry, my mistake. Only
So
phenyl.
2-phenyl,
So 2-phenyl.
3-methyl.
Not 3-methyl. It is propane now. That's all.
Oh, yes, propane.
It's propane. It's covered in that. Got it?
Yes, sir.
Correct. Next. Third special cases, where we have to write the IUPAC name properly is when you have two functional group, but both of them are in different uh, groups here. Suppose if you have COOH here, and then I have COOH here with a double bond here. All right. Now think what should be the name? Because now the problem here is you need to give priority to either of the straight chain or the cyclic chain. Got it? Now look at this. Cyclic chain contains double bond. Straight chain does not contain double bond, because problem here is not the priority of the functional group, because both of them are equal. Then you have to check out for which contains double bond. So cyclic will contain double bond. So that should get more priority. Therefore, the naming would start from here. 1, 2, 3, 4, 5, 6. That's how the naming would be. Okay. Now, can you do it further? You know that COOH is called carboxy. This name is carboxy. This entire COH together is called carboxy. So can you name it now? Please try that. Done? See, this is, you need to check out the number of carbons. 1, 2, 3, 4. So on the fourth carbon, I have carboxy. So you need to write that. On third position, I have 4 carboxy, propyl. This is what is connected. Okay. And this is cyclohex, 2N and 1 carboxylic acid. 2 in 1 carboxylic acid. Check. Nihar, have you understood that? Check.
Yes, sir.
Nanta, how about you?
Yes, sir.
Right, guys, listen. I'll send your login IDs by Thursday for online testing. Saturday, I will upload the first test based on IUPAC. Okay.
Sir, and the website?
I'll send you the details, Vita. Okay.
Sir, and if possible, can you shift today's class to Monday or Wednesday?
So Wednesday won't be possible for me.
So Monday.
Monday is also difficult for me also, but I have other classes also. All right. So is it not okay with you with this timing, 7 to 8:30?
Actually, the problem is that Wednesday I get a lot of homework. So on Tuesday, like after I come at around 2 to 3, then I get very less time to do it. And then after this, I have other class. So it ends at 11 o'clock only. So it becomes very tight. So the schedule is very tightly packed this day.
Correct. I do understand that. I'll figure out. I'll talk to others also and see if there is other day I can accommodate.
So you can have on Saturday.
How about Saturday?
So Saturday evening for the offline batch, Arun sir has kept an extra class. He's asked us not to keep any class at that time.
What is the timing?
So 7 to 8:30 or 8:45.
7 to 8:45.
Yes, sir.
And that's offline or online?
Online, sir.
Online. Okay. Right. I'll speak to Arun once. I'll see if is okay to take it a little late or Saturday usually.
Sir, I will not be free on Saturday.
Completely.
Yeah. No, 1 minute.
See, Saturday
You
normally
can keep
I'll
on
get.
Saturday at 4 to 6 or
That's
something
what I
like
was
that,
coming to.
but not late night.
That's what I'm coming to. Saturday, my option will also be about 5 to 6:30 like that.
To 30. Okay.
Sir,
That
Yes, sir.
Vrinda, would that be fine?
Yes, sir.
Sir, I will still confirm about that 5 to 6:30 timing in the group.
sir, I'm not free at 5 from 5 to 6:30 on Saturday.
You said you had class from 7.
Yes, sir, but I have another class before that.
Okay, you have another class.
Sir,
Fine, I'll do one thing. I'll check with your I'll inform Vimy ma'am to arrange it some way. She'll talk to you guys and check what is the best she can accommodate. Okay. Either she'll ask Arun sir to shift a bit one day so that we can accommodate ours. Okay.
Sir, Wednesday